You want to make sure that you've got an adequate workforce to operate that equipment to produce, the desired result. So, if the contractor doesn't have an adequate workforce, that's going to be a problem. You definitely need to have it. Um, Cure time is the next thing. Cure time is important to not only the agency, but the contractor and ultimately the end user. The fewer delays that we have, the better off we all are. But keep in mind that cure time is not typically relatable back to performance. Some specifications state that rolling traffic should be able to roll on a microsurfacing application within an hour of treatment. Well, every situation is different, and you need to consider that. But if it takes an hour and 5 minutes before you can roll traffic on that, it doesn't mean that there's any issues with performance down the line. And in fact, contractors are responsible for protecting the material from traffic damage prior to opening, and if there is traffic damage, they have to repair it. So I typically like to lean on the contractor to make this decision. They obviously can work together with the agency, but a lot of times it's extremely difficult to even change your traffic control situation around to where you can have rolling traffic on it within an hour. Now, cross traffic is a totally different story, and there are some things that you can do with that that'll be discussed later on in this presentation by Dave Kaiser with Terry Asphalt. But rolling traffic and cure times is important. It behooves the contractor to have a quick mix. It behooves the agency and also the end user. So you can always tweak that a little bit, make it quicker or slower, not only in the field, but maybe even dealing with your emulsion supplier back at the plant. The next thing to evaluate is workmanship. Is the workmanship acceptable? Did the contractor exhibit that their forces can put down the material according to specifications? Is there something that we want to do with the texture? Some agencies love the texture that a burlap material leaves. Some like it better with the secondary strike off, which will be discussed later in this presentation as well. So during this test strip is when you can work together with the agency to determine that stuff. But ultimately, the workmanship needs to be good. And then proper alignment. You want to make sure that the joints of the test strip are put on lane lines, and the driver has got a good mark to drive off of to leave a good straight line behind it. So these are just some of the things that you need to consider when evaluating a test strip. Okay, what happens if you have an unsatisfactory test strip? Well, you got to go back to the drawing board. Now that doesn't mean a whole lot. That doesn't mean you have to recalibrate. That doesn't mean you have to do any of that kind of stuff. It just means that you need to go back and identify the area where improvement is necessary, adjust and perform the test strip again, and repeat as necessary until successful. Again, I like these test strips to be part of the project itself. And in most cases, let me go to this next slide. In most cases, test strip placement, evaluation, and acceptance generally take place on the same day and within a short period of time. So if you're doing a 1,000-foot test strip at 8:30 in the morning, you do your 1,000 feet, you stop, everybody walks up and down it, you check your application rate, everybody talks about surface texture, they go through all the evaluation measures and say, yes, this is an acceptable test strip, go to work. Then it's time to go to work and get busy. So that's how it typically happens. Multiple test strips, waiting overnight, doing things of that nature. If that's what you want, you need to make it part of your specification, but please know that keeping these large crews and equipment from working typically costs money. So the quicker we can do that calibration, test strip, if everything's right, then it's time to go to work. Okay, traffic control. There's several reasons we do the traffic control. First of all, safety of the traveling public, safety of the employees performing the work, product protection, And then when we talk about devices, the traffic control devices, needs are going to vary depending upon the situation. Now, one thing I like to do, and we see it required in a lot of cases these days, is the requirement of ATSA certified traffic control supervisors and technicians. It's important to have those guys on the job. It keeps safety as it relates to traffic control first and foremost, and part of the culture of what you need to do. So extremely important. You see in this picture here, um, this is an urban arterial. Actually was being done on a Sunday because of the high volume traffic, and you can still see the great lengths the contractor has to go to protect the area in which they're working, and to protect the product itself. If you don't do that in some cases, people will drive all through it. They'll run between the cones and things of that nature and just destroy what you've just done. So you have to take that extra step to help protect everything and provide a good, safe work zone. All traffic control devices shall conform to the requirements of the Manual on Uniform Traffic Control Devices. I typically like to make this point during my presentations that this Manual on Uniform Traffic Control Devices, known as MUTCD, I believe that the highest subscribers to that manual are attorneys and not contractors and engineers. So if you're not adhering to the traffic control requirements within that manual, you leave yourself kind of exposed to legal activities, and that's not a good thing. So make sure you're compliant with that document and any local standards that may be in the contract documents as well. Traffic control shall be concise and easily understandable. We've all driven through work zones where you're scratching your head, you're looking around, it can be very confusing, and it's important that you not have a lot of conflicting type signing. Now, in these particular pictures, you can see that people are adhering to the signage that's been put in place. And sometimes that's what it feels like when you're out there working on the roadway. But this is actually, it's just a little levity in the middle of a presentation. But when they say no fishing from the bridge, you'd think that people wouldn't fish from the bridge. Another thing, we talked about being concise and not conflicting. How can you have a stop sign that says no stopping at any time? Which one do you pay attention to? And of course, this sign right here, not really for sure what directive that's given you, but very confusing. So we don't want that. Again, clear, concise, use good devices, don't let them be worn out, covered with dirt and dust and asphalt. This is what protects your people and protects the traveling public. So you want to put a lot of effort into it. And ultimately, you don't want to be this guy. You don't want to be this guy right here. Wear your PPE and pay attention. Have eyes in the back of your head. It's very important. Let's talk about application now. Okay, we're gonna cover a few different subjects within this, and again, within the design and inspection manual, there is a plethora of different subjects that goes along here. Again, we've had to take and cherry pick for this presentation, which is about 3 hours. We've probably really got more 12 to 15 hours worth of information within that design and inspection manual if you put it all into presentation form. And so we really cherry picked. So the advantages of getting that document in your hands is really important. So you can see all of the different scenarios and twists and turns that are within that document. So let's talk about ambient conditions for application. Contributing factors that affect break and cure, obviously humidity, wind conditions, temperature, both surface and air, and potential rain. Okay, slurry surfacing material, which is slurry and microsurfacing, shall not be applied if either the pavement or air temperature is below 50 degrees Fahrenheit and falling, but may be applied when both pavement and air temperatures are above 45 and rising. No slurry surfacing shall be applied when there is a possibility of freezing temperatures at the project location within 24 hours after application. The slurry surfacing shall not be applied when weather conditions prolong opening to traffic beyond a reasonable time. Now, again, humidity. It can potentially slow down the rate of breaking and setting of the slurry surfacing material. That's potentially. Now, those of us that work in high humidity areas and have dealt with material sources for decades, we've got a pretty good handle on this. Humidity doesn't typically have an enormous effect. We know how to formulate our emulsions and our mix designs and job mix formulas to contend with that. So typically not a big deal. Wind conditions. Slight breeze is always advantageous. It's great for the workers too, rather than to have not a breath of air out there. Less humid conditions with a breeze may accelerate the breaking because that water has a place to go now, and it also helps speed up the process of the setting of the slurry surfacing material. Temperature, both air and surface, minimum 50 and rising. That's always important. Work should not be started if freezing temperature is expected within 24 hours. That's the key. That's the rule of thumb right there. Some specifications in different states may vary slightly from that, but that's pretty much a good industry standard. It's also important to know if you're dealing and flirting with freezing temperatures that asphalt emulsions will be ruined if the water in that emulsion is allowed to freeze. You have a big mess on your hand. Don't push the envelope on trying to put these treatment downs in weather that's not conducive to producing a product that's going to give you great performance. Potential rain. Work shall not be started if rain is imminent. And people a lot of times ask me, what does imminent mean? Well, if it's about to rain, you don't need to put it down. We do have quick set materials these days, and microsurfacing will resist rain, induce damage, after about 1 hour of being applied, depending upon, the amount of rain that you may get and how quick you have to put traffic on it. So everybody these days has radar and weather on their cell phones. Keep an eye to the sky. And just, err on the side of caution. The last thing you want to do is get out there and create a mess, have to redo things again. So just be prudent, work with the agency, and ultimately the contractor is responsible for providing a good project. And if he makes a bad call and gets hung in the weather, then it's going to cost him. He's going to have to go out and make those repairs to the satisfaction of the agency that he's working for. Now, this slide is really just an example of, or maybe a way that I can explain how temperature can have an effect on cure times. Now, this is really based on emulsion temperature and not the environmental temperature. But again, I'm trying to illustrate what can happen with temperatures. So you've got available mix time up the left side of your graph here, and you got emulsion temperature here. So if you're looking at 150 degree emulsion here, well, you're only going to have less than, probably 35 or so seconds of mix time. Now that's a hot emulsion, and we typically don't receive them on the job site at that temperature, but it does show you, because of that heat in that emulsion, we're going to have a much more reduced mix time availability. Now, if we get back over here to 110, you see that time is increased up to 150 seconds of mix time. Yeah, now we're getting more in the ballpark. So that's a good thing. And then if we get over here to 90, look, we're all the way up to 300 seconds. So no doubt in my mind that 300 seconds worth of mix time, contractor can adequately mix and get that material placed without any trouble as far as temperature relations go. So again, it is emulsion. It's not the best example, but it does kind of illustrate that weather conditions do have an effect on breaking, curing and being able to reopen to traffic. And if you're in a sunshiny area with a good breeze, you're going to get quicker return to traffic times than you are in a low-lying area that's cool with canopy over the roadway, tree canopy over the roadway with no sunshine and cooler pavement temperatures. You can go from one to the other on the same roadway and see a difference. So please know that stuff in that low-lying area with the cooler pavement temperatures and no sun is going to cure slightly different than that you find in full sunshine. So just an example of what you may see out there in the field. Okay, slurry systems bonding. Okay, again, as I mentioned earlier, if we can't bond to the existing pavement, we're not going to perform. That's just the bottom line. It will never, ever work, not in a million years, and that's any thin non-structural surface treatment. It doesn't matter whether it's a chip seal, a fog seal, a thin overlay, a slurry, or a microsurfacing. If we're not bonding, we're not performing. So the integrity of a slurry system treatment is ensured by creating that strong bond to the existing pavement. And sometimes to help with that, we pre-wet the existing pavement. Now, I'm not going to say that that's a hard, fast, 100% of the time rule, but I'm going to say that more often than not, it is the rule. The whole idea here is to settle any possible particulates that may still be out there. It also helps break a little surface tension with the existing pavement and ensures that bond. It also helps, and this may be a bad word in some people's book, but I think it helps with what I like to call drain down. So, that this is a product that doesn't get tacked, so it does require some emulsion from the mix to slightly drain down to form that membrane and bond with the existing pavement. This dampening of the pavement definitely contributes to that and aids in a good bond. Again, another video that's not going to work here, but you can see how slight dampness under this machine, not ponding water, not rolling water, just slightly dampened, and it helps not only cool that pavement slightly, but it's going to help with that bond. Okay, let's talk about scratch coats. Now, this is only with microsurfacing. When we talk about leveling, cannot do it with Slurry Seal. Slurry Seal is designed for 1 stone thickness. Microsurfacing, you can stack stones and do leveling, which is done through either a scratch course or a rut fill. Let's talk about scratch coats first. Used only with microsurfacing to level pavements with minor transverse irregularities that are narrower than the width of the spreader box, or on pavements with longitudinal ruts less than 1/2 inch. So with a scratch course, if you're 1/2 inch or below, that's what you want to use. If you're over 1/2 inch, then you want to use a rut box. You can see here in this picture on the left, scratch course being applied. This is back during the day where typically the scratch course was laid just narrower than the actual lane width itself. Some people have modified that application process as we have, and we do full width scratch courses now, and try not to do this process because at times that could create a little bit of a ponding issue down the roadway. So not a bad way. Some contractors can do it, some prefer not to. Now, scratch courses are used to correct minor transverse and longitudinal pavement deformation, and again should only be applied with microsurfacing. One of the big differences with a scratch course over surface treatment is you use the same spreader box, but what you do is you use a different screed in that box. Okay, we want a rigid strike off screed, and in a lot of cases some people use metal strike offs or screeds. Some use very rigid polyurethane strike offs. We typically use the urethane ones. They seem to work very good. The whole idea of a scratch course is to scratch or wipe very thinly the material in the high parts of the roadway that I'm pointing at right there. One of the main things we want to remember here is we do not want a lot of buildup on these high parts. If we build up a lot of microsurfacing material on those high parts, ultimately what we've done is we've exaggerated the rut depth of that rut and required more material to be used to fill that rut. Well, that's not a good process. Our material per ton is extremely expensive. Maybe not extremely expensive, but it's expensive. And we don't want to overuse it if we don't have to. So we do not want to exaggerate that. We want to scratch here, wipe it as thin as we can. And a lot of times when we do that, we leave little scratch marks out there on those high spots. So that's not, you may see a little bit of surface texture difference between what's applied here and what's applied here, but that's going to be taken care of when the final surface treatment is put over the top of it. So again, scratch them here. Don't let that material be built up because it's going to require yourself to use some more material. Okay, during the placement of a scratch coat, individual pieces of aggregate, this is what I was just talking about on the high spots there, may be caught by the spreader box and pulled along the road surface, creating drag marks. I like to call them more scratches because they're not very deep because the material is not very deep. This should be expected between wheel paths and on high spots. When the surface texture of the existing pavement is non-uniform, the surface of the microsurfacing will also be non-uniform. Therefore, a scratch course may be needed prior to an application of the final surface to create a uniform surface texture as the final project lift. Okay, rut filling. Use microsurfacing as a rut filler when the pavement is structurally sound for the future traffic over the expected life of the microsurfacing. When ruts were caused by mechanical compaction of the pavement structure. When ruts are flat, not sharp, and showing dual wheel marks. Don't want to use it in that case. When ruts are indentations only, not an indentation between upward heaves. You only want to use it when ruts do not contain fatigue or alligator cracking, and you want to do it when ruts are not caused by base or subgrade failure. So really the purpose of this slide is to reinforce to the designers that they need to do their due diligence in picking candidates for rut filling. Microsurfacing is a fantastic rut filling material when used in the proper application. If required to put these materials in areas where you've got pushing and shoving and ruts that came on quickly to an asphalt pavement, in the second or third year, things of that nature, those are red flags that may indicate that it's not a good candidate for this process. So again, do your due diligence. If you're unfamiliar with where a rut filling treatment may work good for you, don't be afraid to call an industry. There's technical advisory committees and things of that nature that you can find at slurry.org. We've got great technical support, and we always have somebody close by that can probably come out and take a look and give you some advice on a roadway as to whether it would be a good candidate for rut filling or not. So again,